Hello everyone, welcome to 10.0 Upper Roof Trusses, Truss Builder, TTD. Today we're finally going to start building. What we have so far are sketches or the ideas of our frame system. We have ideas of walls and which ones are load bearing and non-load bearing. We have sketched out ideas of what our trusses look like. They are hipped, they have a specific pitch. But as you can see, those trusses have no detail. There are no framing elements visible in this 3D view, just ideas of trusses. Looking at our floor system, it seems like it's detailed, but it's still just the idea of the shape of the floor system, the direction of the joists, and really not much else. When using FrameCAD structure to design buildings, we typically sketch these ideas out and hammer out all of the details of the building, including loading, code, earthquake, wind, shape, direction of trusses or joists, bearing, non-load bearing, placement, openings. In this exercise, we're finally going to start building. And when we start building, we start at the top and we progressively move our way all the way down to the first floor. So in this series of exercises, we will use Truss Builder for the upper roof. We will use Panel Builder for the walls on the second floor. Joist Builder for the floor system that supports the walls. Truss Builder again for the lower roof trusses. And Panel Builder again for the first floor walls. And the reason why we start building from top to bottom is once we start building, those elements become finalized. And so once I finalize the upper roof trusses, I now have enough information in terms of gravity load as to what the walls on the second floor need to look like, because there's a definitive design for the trusses above them. We'll see every single stick, top plate, bottom plate of each of those trusses. And once we build that, once we design that, we can move on to designing and building the second story walls, which have their own openings. And then we can move down to the floor system once we have a definitive idea of the second floor walls and upper roof trusses, and so on and so forth. So when it comes to building and structure, we start at the very top and progressively work our way to the bottom. We're going to start by moving our upper roof trusses from border number 6 to border number 5. V enter, 6 enter. MV will select all of the roof trusses and polylines, but we won't select the reference point. Hit enter. We're going to click border number 5. 1, 2, 3, 4, 5. Now we need to check our truss settings. So T-set. Navigate to the Options tab. Filter Options. current view only, and set that to true. Click Save. Unless you already had it set to true, then click Cancel. Now that we have our trusses in the correct border, our truss settings are updated. We can now engineer the trusses in this view. Quick navigate to border number 5. Initiate the Truss Builder command, TTD. Once you get to this dialog box, make sure you expand this window enough so you can really read the information. Make sure you expand this navigation pane as well. This is the Truss Builder. Notice the tabs at the top of the Truss Builder dialog box. Fabrication, Bill of Materials, Engineering, Truss Results, Detail, Design, Drawing. I go over each one more into detail in the handout. On the far left side are our truss results. You might see some that fail. We're going to select Alt and 2CAD. Notice that we are now in a new tab called Truss Point 1. Let's begin exploring this detailing space for Truss Point 1. When zooming out, I can see that I have multiple borders, each with their own unique design for a truss. Even from this far out, I can see there is some green text at the bottom of some of these drawings and red text. Green means the design for this truss passes the engineering status. Anything under 100% is a passing grade, while anything over 100% is marked with red. Understanding the status of your trusses and engineering passes and fails is essential. Trusses that fail engineering the calculation must always be addressed and modified to pass the checks to ensure a fully compliant, safe design. Double-click on your middle wheel button on your mouse to zoom extents. Let's quick navigate to View or Border number 1. V, enter, 1, enter. You can see that even in this Truss Point 1 layout, I can quick navigate to all 28 of these borders. In the command line, type TTD to bring up the Truss Draw Builder dialog box. We can see the engineering status is passing because the text is green. Let's edit the web spacing of the truss. Double-click on the truss in the truss results. Scroll down to Web Information. And change the web spacing to 2'6". Click the Keep button. Notice that the web spacing has now adjusted and the engineering status has also changed. Click on the Update button. Let's zoom out and find a detail sheet that shows a failing truss. Here, border number 26 is failing. V, enter, 26, enter. TTD. In the top right corner of the dialog box, click on the Engineering Status button. This view highlights where the truss is failing. Anything over 100% has failed the engineering status check and is marked in red. An engineering results legend is placed at the top left corner of this view as a reference guide. When it comes to fixing a truss, there is no one correct way to do it. There are multiple ways to resolve a truss failure. We can adjust the truss material or adjust the web members and spacing. We're using an LE truss, which means the top and bottom chords are oriented flat. We also have the option of reinforcing our truss. When we initially adjusted the last truss, we edited the spacing, so this time we will focus on changing the material of the truss and reinforcing the top and bottom chords instead. First, list the truss from the truss results list by double-clicking its name on the truss results navigation pane. Scroll down to the material selection. There are two things to keep in mind when you change the thickness of the material. Make sure that you have steel coils of the designated thickness in stock for when you manufacture your project. And you will need to change the material out and manufacture this truss separately from the rest of the design. If you have multiple machines, it may be more convenient to produce this truss using a separate machine. Change the values for the bottom chord, top chord, web, and rail to 350S 1623370LE. Click the Keep button. The engineering status for this truss has now been updated. Now let's focus on reinforcing the top and bottom chords. List the truss by double-clicking its name on the truss results navigation pane. Scroll down to the material section. Change the bottom quantity and top quantity from single to double. Keep. The engineering status for this truss has now been updated and is passing. The engineering status for this truss has now been updated, but is not passing. Let's try something else. Looks like decreasing the web spacing and changing the web pattern to type 4 brought our engineering status to a passing status. Let's change our top and bottom quantity back to single. Keep. The engineering status for the truss has now been updated, is back to failing. In the top right corner of the dialog box, select the engineering status button, making sure that it's on. Our weaknesses are where all the red lines are. Keep in mind these locations as we will be reinforcing this area in the next step. I'm going to change my web spacing back to 4 feet and my web pattern back to type 2, type 3. Instead of reinforcing entire top and bottom chords, we will instead use the bm box member command to reinforce isolated areas of weakness. Click Update. Initiate the box member command, bm. This command will allow us to reinforce our truss by defining 2 points to which the reinforcement will lie. We can have the reinforcement run in either the LE or LC orientation. Zoom in on an area that had structural weakness. To reinforce with an LC orientation, hold down the Alt key on your keyboard. Define 2 points while holding the Alt key. Initiate the TTD command. List the truss. Our truss is almost passing, so we will make one modification and decrease the web spacing to see if that can help. We're only adding more weight. Let's double up the top quantity. That is also not helping. Let's change this back to single. And change the web spacing back to 4 feet. Type 3. Keep. We'll hit cancel. And we'll type in BM. While holding Alt, we will click in this spot and the spot across. TTD. And now our engineering status is set to 94%. We'll click Update. And that's how you can fix those issues. Initiate the T3D command. If your 3D model is not showing a detailed upper roof truss, reinitiate the T3D command. Here are our detailed and built trusses. Make sure when you're in the Truss Point 1 tab, you fix any of your trusses using any of the recommended options from previous. And then update your Truss 3D. Back in Layouts, we're going to add a truss uplift plan to our drawing, which produces a copy of the truss layout plan showing maximum uplift forces at each support location. Type in TUP. With the upper roof trusses centered in your view, type TUP in the command bar and hit enter. The software will zoom out so that you can select a drawing border to add the truss uplift plan to. Select border number 6. Note, not all trusses will have an uplift value shown. This is due to the note placed in the top center that says all values over 0.25 kip are shown and all other values are ignored. This value can be changed in TSET under the Options tab and then under Report Options. Make sure to take a screenshot of your most up-to-date 3D model, as well as your Truss Point 1 tab, fully zoomed out for the assignment. And that's it for Truss Builder. Thank you very much. I'll see you in the next exercise where we work on the panels of the second story.